The relationship strength concept is not part of the original ERM. Instead, this concept applies directly to Crawford diagram because Crawford diagrams are used extensively to design relational database. It's important to understand relationship strength as it affects database implementation. The term ERD notation is oriented towards conceptual modeling and therefore does not distinguish between weak and strong relationships. The term ERD notation is oriented towards conceptual modeling and therefore does not distinguish between weak and strong relationships. The term ERD notation is oriented towards conceptual modeling and therefore does not distinguish between weak and strong relationships. A weak relationship, also known as a non-identifying relationship, exists in the primary key of the related entity. There's the exists if the a weak relationship, also known as non-identifying relationship, exists if the primary key of the related entity does not contain a primary key component of the parent entity. By default, relationships are established by having the primary key of the parent entity appears as a foreign key on the related entity. For example, Sierra's class code is different. The concept relational strength is based on how the primary key of a related entity is defined. To implement a relationship, the primary key of one entity appears as a foreign key in the related entity. The primary key of one entity appears as a foreign key in the related entity. To implement a relationship, the primary key of one entity appears as a foreign key in the related entity. For example, the one-to-many relationship between vendor and product is implemented by using the Bancode primary key and vendor as a foreign key in the product. There are times when the foreign key also is a primary key component in the related entity. There are times when the foreign key also is a primary key component in the related entity. For example, the car entity primary key appears as both a primary key component and a foreign key in the car color entity. There are times when the foreign key also is a primary key component in the related entity. Like the car entity primary key appears as both a primary key and a foreign key in car. In this case, a weak relationship exists between cars and class because the class code is the class entity primary key, while the Sierra's code in class is only a foreign key. In this example, the class primary key did not inherit the primary key component from the class entity. The class primary key did not inherit the primary key component from the class entity. Crawford's notation depicts a weak relationship by placing a dashed relationship line between the entity. Depicts a weak relationship by placing a dashed relationship line between the entity. A strong relationship, also known as an identifying relationship, exists when the primary key of the related entity contains the primary key components of the parent entity. For example, the definition of the cars and class entity, cars as code, class Sierra's code cross-section, indicates that a strong relationship exists between cars and class because the class entity composing primary key is composed of Sierra's code and cross-section. Note that the Sierra's code in class is also the foreign key to the cars entity. If you are using to looking at relational diagrams like ones produced by Microsoft Access, you expect to see the relationship line in the relational diagram drawn from the primary key to the foreign key. However, the relational diagram convention is not necessarily reflected in the ERD. If you are used to looking at relational diagrams like ones produced by Microsoft Access, you expect to see the relationship line in the relational diagram drawn from primary key to the foreign key. However, the relational diagram convention is not necessarily reflected in the ERD. In an ERD, the focus is on the entities and the relationship between them rather than on the way those relationships are anchored graphically. You will discover that the prism of the relationship lies in the compressed ERD that includes both horizontally and vertically placed entities. It is largely dictated by the designer's decision to improve the readability of the design. Remember that the ERD is used for communication between the designers and users. ERD is used for communication between the designer and end users. Remember that the ERD is used for communication between the designers and end user. ERD is used for communication between the designers and end users. ERD used for communication between designers and end user. The Crawford notation depicts the strong identifying relationship with a solid line between the entity. The Crawford notation depicts the strong identifying relationship with a solid line between the entity. Whether the relationship between cars and class is strong or weak depends on how the class entity primary key is defined. Whether the relationship between cars and class is strong or weak depends on how the class entity primary key is defined. Keep in mind that the order in which the tables are created and loaded is very important. For example, in the cars generate class relationship, the cars table must be created before the class table. After all, it would not be acceptable to have the class table foreign key reference a cars table that did not yet exist. Class table foreign key reference a cars table that did not yet exist. And in fact, you must load the data of the one side first in a one-to-many relationship to avoid the possibility of referential integrity errors, regardless of whether the relationship are weak or strong. Load the data of one side first in a one-to-many relationship to avoid the possibility of referential integrity errors. Whether the relationship between cars and class is strong or weak depends on how the class entity primary key is defined. Remember that the nature of relationship is often determined by the database designer, who must use professional judgment to determine which relationship type and strength best suit the database transaction efficiency and information requirements. For example, a company insurance policy insures an employee and his/her dependent. For the purpose of describing an insurance policy, an employee might or might not have a dependent, but the dependent must be associated with an employee. Moreover, the dependent cannot exist without the employee. That is, a person cannot get insurance coverage as a dependent unless that person happens to be the dependent of an employee. The dependent is the weak entity in the relationship. Employee has dependent. For example, a company insurance policy insures an employee and his/her dependents. For the purpose of describing an insurance policy, the dependent must associate with an employee. In contrast to the strong or regular entity mentioned, a weak entity is one that meets two conditions. First, the entity is existence dependent. That is, it cannot exist without the entity with which it has a relationship. And second, the entity has a primary key that is partially or totally derived from the parent entity in the relationship. The entity has a primary key that is partially or totally derived from the parent entity in the relationship. The entity has a primary key that is partially or totally derived from the parent entity in the relationship. The entity has a primary key that is partially or totally derived from the parent entity in the relationship. Note that the Chern notation identifies the weak entities by using a double wall entity rectangle The Crawford notation generated by Visual Professional uses the relationship line and the primary key foreign key designation to indicate whether the related entity is weak. The return notation identifies weak entities by using a double wall entity rectangle. And the Crawford notation generated by Visual Professional uses the relationship line and the primary key foreign key designation to indicate whether the related entity is weak. Primary key foreign. A strong relationship indicates that the related entity is weak. Such relationship means that both conditions for the weak entity definition have been met. The related entity is external dependent. The primary key of the related entity contains a primary key component of the parent entity. Some versions of Crawford ERD depict weak entity by drawing a short line segment in each of the four corners of the weak entity bar. Remember, the weak entity inherits part of its primary key from its strong counterpart. For example, at least part of the dependent entity key was inherited from the employee entity. The implementation of the relationship between the weak entity dependent and its parent or strong counterpart employee. The implementation of the relationship between the weak entity dependent and its parent or strong counterpart employee. Note that dependent's primary key is composed of two attributes, mnum and depnum, and that mnum was inherited from employee. Mnum was inherited from employee. And keep in mind that the database designer usually determines whether an entity can be described as weak based on the business rules. Keep in mind that the database designer usually determines whether an entity can be described as weak based on the business rules. An examination of the relationship between class and class might cause you to conclude that class is a weak entity to class. After all, it seems clear that a class cannot exist without a course, so there is external dependence. For example, a student cannot enroll in the accounting unless there is an accounting. And however, note that the class table primary key is class code, which is not derived from the class parent entity. That is, class may be represented by class code. The second weak entity requirement has not been met. Therefore, by definition, the class entity may not be classified as weak. On the other hand, if the class entity primary key have been defined as a composite key composed of the combination of CRS code and class section, class will be represented by like that. In that case, the primary key is partially derived from class. Given this decision, class is a weak entity by definition. Crawford terms the relationship between class and classes I classify as strong or identifying. In any case, class is always existence dependent on class whether or not it is defined as weak. Class code. The second weak entity requirement has not been met. Therefore, by definition, the class entity may not be classified as weak. The second weak entity requirement has not been met. On the other hand, if the class entity primary key has been defined as a composite key, it composed of the combination. In that case, primary key is partially derived, and because CRS code is the class table primary key. Optional participation means that one entity occurrence does not require a corresponding entity occurrence in a particular relationship. In the course generates class relationship, you noted that at least some courses do not generate a class. In other words, an entity occurrence in the class table does not necessarily require the existence of corresponding entity occurrence in the class table. Remember that each entity is implemented as a table. Therefore, the class entity is considered to be optional to the class entity. In Crawford notation, an optional relationship between entities is shown by a small circle on the side of the optional entity. The existence of an optional entity indicates that the minimum cardinality is 0 for the optional entity. The term optionality is used to label any condition in which one or more optional relationships exist. The term optionality is used to label any condition in which one or more optional relationships exist. The term optionality is used to label any condition in which one or more optional relationships exist. Participation in an entity relationship is either optional or mandatory. Recorded relationships are bidirectional. There is that operate in both directions. If clause is related to class, then by definition class is related to clause. Because of the bidirectional nature of the relationship, it's necessary to determine the connectivity of the relationship from class to class and the connectivity of the relationship from class to class. Similarly, there are specific maximum and minimum cardinalities must be determined in each direction for the relationship. Once again, you must consider the bidirectional nature of the relationship when determining participation. Remember that the burden of establishing the relationship is always placed on the entity that contains the foreign key. In most cases, that will be the entity on the many side of the relationship. Establishing the relationship is always placed. Mandatory participation means that one entity occurrence requires the corresponding entity occurrence in a particular relationship. If no optionality symbol is depicted with the entity is assumed to exist in a mandatory relationship with the related entity. If the mandatory participation is depicted graphically, it is typically shown as a small hash map across the relationship line, similar to the Crawford depiction of a connectivity of one. The existence of a mandatory relationship indicates that the minimum cardinality is at least one for the mandatory entity. The existence of a mandatory relationship indicates that the minimum cardinality is at least one for the mandatory entity. Existence of a mandatory relationship indicates that the minimum cardinality is at least one for the mandatory entity. When you create a relationship, it means be sure the default relationship will be mandatory on the one side and optional on the many side. Mandatory on the one side and optional on the many side. These combinations are referred to as cardinality in Crawford notation when specific cardinalities are not used. If the mandatory participation is depicted graphically, it is shown as a small hash map across the relational line, similar to the Crawford depiction of connectivity of one. The existence of a mandatory relationship indicates that the minimum cardinality is at least one for the mandatory entity. You might be tempted to conclude that relationships are weak when they occur between entities in an optional relationship, and that relationships are strong when they occur between entities in a mandatory relationship. However, this conclusion is not warranted. Keep in mind that relationship participation and relationship strength do not describe the same thing. Relationship participation and relationship strength do not describe the same thing. You are likely to encounter a strong relationship when one entity is optional to another. Keep in mind that relationship participation and relationship strength do not describe the same thing. Encounter a strong relationship when one entity is optional to another. The relationship between employee and dependent is clearly a strong one, but dependent is clearly optional to employee. After all, you cannot require employees to have dependents, and it's just as possible for a weak relationship to be established when one entity is mandatory to another. The relational strength depends on how the primary key of the related entity is formulated, while the relationship participation depends on how the business rule is written. For example, the business rule each part must be supplied by a vendor, and the part may or may not be supplied by a vendor. Create different optionalities for the same entities. Failure to understand this distinction lead to poor design decisions that cause major problems when table rows are inserted or deleted. It create different optionalities. It create different optionalities for the same entities. Create different optionalities for the same entity. It creates different optionality for same entity. Each part must be supplied by vendor and the part may or may not be supplied by vendor. Many site is optional on the 0, and one site is also optional if the starting is 0. But if the starting is a 1 to many or 1 to 1, then the many and site, the second part is mandatory. Because relationship participation turns out to be a very important component of the database design process. Suppose that tiny college employs some professors who conduct research without teaching class. Professor teach class, it's quite possible for a professor not to teach a class. Therefore, class is optional to professor. On the other hand, the class must be taught by a professor. Therefore, a professor is mandatory to class. Professor is mandatory to class. Note that the ERD model shows the cardinality net the class to be 0 true, thus indicating that a professor may teach no classes at all, as many as 3 classes, and each class table row will reference 1 and only 1 professor row, assuming each class is taught by 1 and only 1 professor, represented by the 1-1 cardinality next to the professor table. Further, to understand the distinction between mandatory and optional participation in relationships, my year designs in which awkward and unnecessary temporary roles must be created just to accommodate the creation of the required entity. Therefore, it's important that it's also the semantics of a problem might determine the type of participation in a relationship. A relationship degree indicates the number of entities or participants associated with a relationship. Relationship degrees indicates the number of entities or participants associated with a relationship. A relationship degree indicates the number of entities or participants associated with a relationship. A relationship degree indicates the number of entities or participants associated with a relationship. A relationship degree indicates the number of entities or participants associated with a relationship. Number of entities or participants. A unary relationship exists when an association is maintained within a single entity. A binary relationship exists when 2 entities are associated. Ternary exists when 3 entities are associated. Although higher degrees exist, they are rare and are not specifically named. For example, an association of 4 entities describes simply as 4-degree relationship. In the case of the unary relationship, an employee within the employee entity is the manager for 1 or more employees within that entity. An employee within the case of unary relationship, an employee within the employee entity is the manager for 1 or more employees within that entity. Employee within the employee entity is the manager for 1 or more employees within that entity. In this case, the existence of the managed relationship means that employee requires another employee to be the manager that its employee has a relationship with itself. In this case, the existence of the managed relationship means the employee requires another employee to be the manager, that its employee has a relationship with itself. Such a relationship is known as recursive relationship. Although most relationships are binary, the use of ternary and higher order relationship does allow the designer some latitude regarding the semantics of a problem. A ternary relationship implies an association among 3 different entities. Note that the relationship and the consequence which are represented by the following business rule. A doctor writes 1 or more prescription, patient receives 1 or more prescription, drug may appear in 1 or more prescription. To simplify this example, assume that business rule states that each prescription contains only 1 drug. In short, if doctor prescribe more than 1 drug, a separate prescription must be written for each drug. As you examine the table contents, note that it's possible to try our translations. A binary relationship exists when two entities are associated in a relationship. Binary relationships are most common. In fact, to simplify the conceptual design whenever possible, most higher-order relationships are decomposed into a proper equivalent binary relationship. The relationship of professor teaches one or more class represents a binary relationship. The relationship of professor teachers one or more classes represents a binary relationship. The relationship of professor teachers one or more classes represents a binary relationship. As was previous, a recursive relationship is one in which a relationship can exist between occurrences of the same entity set. Naturally, such a condition is found with a unary relationship. Like one-to-many unary relationship can be expressed by an employee may manage many employees and each employee is managed by one employee. An employee may manage many employees and each employee is managed by one employee. And as long as polygamy is not legal, one-to-one unary relationship may be expressed as an employee may be married to one and only one other employee. Finally, the many-to-many unary relationship may be expressed as a cause may be a prerequisite to many other cars, and each cars may have other cars as prerequisite. One common pitfall when working with unary relationship is to confuse participation with referential integrity. In theory, participation and referential integrity are very different concepts and are normally easy to distinguish in binary relationship. In particular term, conversely, participation and referential integrity are very similar because they are both implemented to constrain on the same set of attributes. This similarity often leads to confusion when the concepts are applied in the limited structure of a unary relationship. Consider the unary one-to-one relationship of a spousal relationship between employees. Participation as described above is bidirectional, meaning that it must be addressed in both directions along the relationship. The one-to-one relationship of a spousal relationship between employees. Participation as described above is bidirectional, meaning that it must be addressed in both directions along the relationship. The unary one-to-one relationship of a spousal relationship between employees. Participation as described above is bidirectional, meaning that it must be participation. The unary one-to-one relationship of a spousal relationship between the unary one-to-one relationship of a spousal relationship between employees. Participation as described above is bidirectional, meaning that it must be addressed in both directions along the relationship. Participation addresses the question: must every employee have a spouse or is an employee? If the correct answer to both data is no, then it's possible to be an employee and not have another employee as spouse. Or is it possible to be an employee and not a spouse with another employee? Referential integrity deals with the correspondence of values in foreign key with values in the related primary key. Referential integrity deals with the correspondence of values in the foreign key with values in the related primary key. Referential integrity deals with the corresponding values in the foreign key with values in the related primary key. Referential integrity is not bidirectional, therefore it's only one question that it answered. Must every employee it only has one question to answer. In the original ERM described by Chern, relationships do not contain attribute. You should record that relational model generally requires the use of one-to-many relationship and one-to-one relationship has its place, but it should be used with caution and proper justification. Associative entity. If many-to-many relationships are encountered, you must create a bridge between the entities that disperse such relationship. The associative entity is used to implement a many-to-many relationship between two or more entities. This associative entity, also known as a composite or bridge entity, is composed of the primary keys of each of the entities to be connected. The associative entity is used to implement a many-to-many relationship The associative entity is used to implement a many-to-many relationship between two or more entities. The associative entity is used to implement a many-to-many relationship between two or more entities. This associative entity, also known as a composite bridge entity, is composed of the primary keys of each of the entity to be connected. In practical terms, both participation and referential integrity involve the values used as primary key, foreign key to implement the relationship. Both participation and referential integrity involve the values used as primary key or foreign key to implement the relationship. Referential integrity requires that the values in the foreign key correspond to values in primary key. Referential integrity requires that the values in the foreign key correspond to values in the primary key. Referential integrity requires that the values in the foreign key correspond to values in the primary key. Referential integrity requires that the values in the foreign key correspond to values in the primary key. Referential integrity requires that the values in the foreign key correspond to values in the primary key. In one direction, participation considers whether or not the foreign key can contain or not. In the other direction, participation considers whether or not every value in the primary key must appear as a value in the foreign key. In one direction, participation considers whether or not the foreign key can contain or not. Participation considers whether or not the foreign key can contain or not. In one direction, participation considers whether or not the foreign key can contain or not. And in other direction, participation considers whether or not every value in the primary key must appear as a value in the foreign key. Note that composite annual entity and sister depend on the other two entities. The composition of the annual entity is based on the primary keys of the entities that are connected by the composite key. The composite entity may also contain additional attributes that play no role in the connective process, or the entity must be composed of at least the student and class primary key. It may also include such additional attributes like grades, absence, and other data uniquely identified by the student's performance in their specific class. And keep in mind that the enroll table's key is composed entirely of the primary keys of the class and student table. Therefore, no null entries are possible in the enroll table key attribute. The enroll table key is composed entirely of the primary keys of the class and student table. The enroll table's key is composed entirely of the primary keys of the class and student table. Enroll table key is composed entirely of the primary keys of the class and student table. Therefore, no null entries are possible in the enroll table key attribute. A class may exist at least at the start of registration, even though it contains no students. Therefore, if you add an optional symbol should appear on the student side of the many-to-many relationship. Like, a class is mandatory to the student from a purely conceptual point of view. However, when the student is admitted to college, the student has not yet signed up for any class. Therefore, at least initially, class is optional to student. Note that the practical consideration data environment help dictate the use of optionality. If class is not optional to student from a database point of view, a class assignment must be made when the student is admitted. If class is not optional to student from a database point of view, a class assignment must be made when the student is admitted. But that's not how the process actually works, and the database design must reflect this. Implementing the smart, you must know the one, the many sides of relationship, and you must know where the relationship are mandatory or optional. Because the many-to-many relationship between student and class is decomposed into two one-to-many relationship through enroll, and the optionalities must be transferred to enroll. In other words, now become possible for a class not to occur in enroll if no student has signed up for the class. Because the class need not occur in enroll, the enroll entity becomes optional to class. Because the class need not occur in enroll, the enroll entity becomes optional to class. And because the enroll entity is created before any students have signed up for a class, the enroll entity and because the enroll entity is created before any students have signed up for a class. And because the enroll entity is created before any students have signed up for a class, enroll entity is also optional to students, at least initially. Because the class need not occur in enroll, the enroll entity becomes optional to class. Because the class need not occur in enroll, the enroll entity becomes optional to class. And because the enroll entity is created before any students have signed up for a class, the enroll entity is also optional to students, at least initially. Because the class need not occur in enroll, the enroll entity becomes optional to class. And because the enroll entity is created before any students have signed up for a class, the enroll entity is also optional to student. And because the enroll entity is created before any students, also optional to students. Composite entity may also contain additional attributes that play no role in the cognitive process. Although the entity must be composed of at least student and class primary keys, it also includes such additional attributes like grades, absences, and other data. Keep in mind that the enroll table key is composed entirely of the primary keys of the class and student. Keep in mind that the enroll table key is composed entirely of the primary keys of the class and student table. Therefore, no non-entries are possible in the enroll table key attribute. The enroll table's key is composed entirely of the primary key, so no non-entries. A student's